Hello everyone, I'm Naveen, and in these sessions I'll be talking about functional patterns in domain-driven design. We will see which concepts of domain-driven design make sense in functional language such as Clojure, and if they do, how to implement them in most functional way. We will also see how implementation of same domain-driven design concept is different in Clojure compared to any other object-oriented programming language. And the most importantly, I'll demonstrate how we can leverage functional abstraction to model our domain-driven design concept better. This is the GitHub repo for online library management system that we are going to build. It is implemented in Java and we will build it in Clojure from scratch. It has a very well-defined problem statement with lot of business rules which makes it ideal candidate for domain-driven design. Additionally, this project has made our job easier in terms of defining domain entities and business processes. I would encourage you to go through this project to understand the domain better. This project has done a good job in terms of identifying domain concepts, and all of this is very well documented in the GitHub repo. So I would encourage all of you to sort of go through it at least once. And we are going to leverage all this domain exploration which has already been done while we do the implementation in Clojure. For instance, user is called patron. So instead of calling a user, I'm going to call it patron. We will primarily use Clojure specs to model our domain. As you can see here, we have defined two domain models, one for patron, another for book. Right now, these models have only few properties. Patron has patron ID and number of hosts. Book has only book ID. We are not going to do any database integration at this point, but we will write methods which simulates database call. So as you can see here, we have two functions. One function find book is responsible for fetching books from database, and the other function find patron, which is responsible for fetching patron from the database. And we will be using Clojure spec generators that would generate models with values for us. Next one is a validation function which takes a book ID and a patron ID as a map. It validates the incoming request by checking whether both book and patron exist. If validation fails, this function returns a map with error, and if validation is successful, it would return success key with patron and book domain entities. We are going to refactor this validation function. The idea is to keep your core domain logic free from if-else conditions. So there are many functional abstractions that you can use to extract if-else logic into some sort of common generic abstraction which can be reused in multiple places. So for this purpose, we are going to use applicative. Like applicative is just the right fit for this particular situation. But before we can dive deep into applicative, we need to understand few functional concepts. And the one I'm going to talk about is a concept of box or a container and pure value. Pure values are any data structure in Clojure. It could be a int, it could be a map, or it could be a string. Basically, any data structure in Clojure could be a pure value. While the idea of box comes from statically typed languages such as Haskell, Scala. However, we can represent this concept of box in Clojure with records. So for instance, I have this success record which represents a successful computation, while value would be any pure value inside it. Let's try to understand the concept of pure values and containers in more detail. I'll take an example, a very simple one, wherein we want to add two numbers. So normally you'll have this plus and then two numbers, which in our case would be 1 and 2, and then you do the addition and you get result back as 3. However, if you wrap these values, which is 1 and 2, in a in a container or a box, this plus operation won't work because plus doesn't support record. So what can we do here? We need a mechanism which would take these values out of this box and then apply the plus operation on top of it. Alright, let's move on to implementation. Here I have defined two records, one success and the other one is failure. So success represent outcome or a result of a successful computation or operation, and failure represent a failed scenario. Like if a computation or a operation fails, we are going to represent it with a failure record. I've also defined two helper methods to create these records. So let's see how we can create them. So success record, you can just create it with this function which is success and pass in a value here. And in similar way you can create failure, which is just calling this method. And an interesting thing about failure is that you might not want to return a value because failure would either contain nothing or maybe it will contain some message which conveys the reasons for failure. So in our case, I'm gonna pass a list with a error tuple, like error or just error. Like I said earlier, we need a way to extract these values out of the box and then apply the desired operation on those values. Fortunately, we don't have to build that mechanism on our own. There is already a library called cats which we can use in order to implement our desired flow. One good thing to know is that these concepts are very common functional concepts. So this thing that we are going to use is called applicative, and you can find it in Scala, Haskell or any other functional language. Alright, so heading back to code again. So as you can see here, I'm importing this namespace cats.core in my file, and this namespace gives me the functionality of applicative. So what we are going to do is we are going to apply this addition of two numbers, but not on the pure values but on the containers. So how we can do it? So this namespace that we have imported, catscore, has a function called app, which is short for applicative, and then you can pass this thing the operation that you want to perform on pure values. So you have to remember the plus still takes pure values, but what we are going to pass it is not a pure value but a value inside a box, which in our case is 1 and 2. Right. And now if I evaluate it, we get back a result with success and value as 3, which is what we want. So this is only the half of the story where it gets really interesting at the failure scenarios. So what I'm going to do is to copy this function again and make first function return a failure. Since this is a failure, I'm not going to return a pure value but rather a list which contains error reasons. In this case, let's say it's not a number, that's what we want to return. And if I evaluate it, I get back a record which lists the error. So there is an error key and the value is a list. Yeah. And if I copy this function again and let's say that both the functions return failure, right? So what is going to happen in that case? Would it return the first error or the second error or the both? So this applicative is sort of intelligent enough to know what to do in case of failure. So it is going to club both the error reasons together. And what you get back is a nice list of errors. So as you can see here, this again returns a failure. a record which with a error keyword and the list which contains both the errors. Now if we go back to the validation function that I showed you earlier and the one which we want to refactor, we had already defined domain spec, the domain model for the book and the pattern. We also defined two functions here for simulating database call. So now if you want to use applicative here, there are like few changes that we need to make. So first thing that we need to do is that we need to create a wrapper around this find book function. So here you can see I have created this function book which looks into the database. If it finds that book, it would return a success with the book entity, and if it is a failure, it's going to return an error saying that book not found. Same thing for pattern. It is going to look into the database, and if pattern is found, then it's going to return a success, otherwise a failure with error as pattern not found. So once you have this success and failure, it's super easy to club them together. So in the validate book hold, we are again using applicative here, and then we are calling this function book hold. So this function book hold is a very simple function. It just creates a map. You just pass in the book and the pattern. And here you can see we are calling this book hold, and then we are calling this book function which returns a success or a failure, and a pattern function which returns again a success and failure with the pattern entity if it is successful. This applicative would call this book hold function only when both of them are successful, and if they are not successful, then it would just return an error tuple. Let's see how that works. And if I evaluate this function, alright, if I call this function validate book hold with a map with pattern ID and the book ID as key, I should get back a record, success record with our domain entities. Remember that we are using Clojure spec generators to generate our domain entities, and that's what we get back in this success record with book and pattern. Yeah, so now if I simulate a different scenario of the failure, like I'm going to return nil from these functions which simulates database call. So both of these functions return nil. And with this, if I re-evaluate this function, this should give me back list, and that's what we get back. So this is a failure record that we are getting back with error key and list of errors.